Hey, and welcome to today's class. Today's class is a continuation of our previous classes on laws of indices. In today's class, we shall be looking at the indices law of subtraction. At the last class, we have looked at the indices law of addition, where the rule states that when two or more indices are being multiplied, so long as their bases are the same, you add their powers. I've been able to prove to you how we come about that and why it is so. So in today's class, we shall be looking at the indices law of subtraction. If you have not watched that of addition, please kindly refer to the previous videos and you'll get it from there. Let us consider what happens when one number in index form is divided by another with the same base. Just like what we did in addition. Example 1 says we should simplify y raised to the power of 7 divided by y raised to the power of 3. This can be written as y times y times y times y times y times y times y. That is 1, 2, 3, 4, 5, 6, 7. Divide by y times y times y. Y will cancel itself 1 times. This will also divide this once, and this will divide this once. Nothing else can divide because we don't have a factor that can divide at the denominator. So at the end, we say this is equal to y raised to the power of 1, 2, 3, 4. Numbers of y that are left, which is y raised to the power of 4. Also, if you look very well, you will discover that the answer we got is equal to when you subtract y raised to the power of 3 from y raised to the power of 7. When you subtract the powers, when you subtract 3 from 7. So therefore, we should note that the power in the final answer is equal to the subtraction of the power of y raised to the power of 3 from that of y raised to the power of 7. So that y raised to the power of 7 divided by y raised to the power of 3 is equal to y raised to the power of 7 minus 3, which is equal to y raised to the power of 4. Could this also be a coincidence? If so, let's see example 2. That we should simplify z raised to the power of 10 divided by z raised to the power of 4. This can also be said to be z times z times z times, this is 4, 5, 6, 7, 8, 9, 10. Divide by z raised to the power of 4, which is z times z times z times z. Now, when you simplify, this is equal to this z will divide itself 1 into this is 1, into this is 1, this will cancel out 1, same with this and this, as well as same with this and this. Nothing else can divide. So that this is said to be z to power 1, 2, 3, 4, 5, 6, z to power 6. Will you also say this is a coincidence? Now, note also that the power in the final answer is equal to the subtraction of the power of z to power 4 from that of z to power 10. So, z to power 10 divided by z to power 4 can be expressed as z to power 10 minus 4, which is equal to z to power 6. So, having these two as evidence, we can now generalize by saying that in general, a to power m divided by a to power n is equal to a to power m minus n. This is called the indices law of subtraction. If there are algebraic expressions with given coefficients, divide the coefficients, the base remains the same, and the powers are subtracted. Just like what we did when we had coefficients in addition, we multiplied the powers and the base remained the same, we added the powers. Same thing with subtraction. When you're dividing two indical problems and they are having coefficients, divide the coefficients and then carry out the indical law of subtraction with those that are indices. Kindly like my videos as you watch. While I recommend that you subscribe to my channel and follow me on Facebook if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can share the links with your friends and families so that they can also benefit from our project. We shall now take another example.